This is Geometry A, Unit 6, Congruent Triangles, Lesson 7, Congruence and Overlapping Triangles. Proving triangles are congruent when they're overlapping can be rather tricky, particularly because it's easy to get lost in the drawing, in the diagram, and I find it helps a lot to separate the triangles. Let me give you an example here. Let's say we've got two triangles that overlap like this. Okay, and so we've got one triangle here. And actually, I'm drawing both triangles simultaneously. It'll become a little more apparent what I'm doing here in a moment. Okay, let's go right there. There we go. Okay, and here, and here. All right, so I'm going to label the vertices A, B, C, D, and E. Okay? And you may see that there are actually probably at least 3 triangles. 1, 2, 3, 4 triangles actually, and a quadrilateral. But the overlapping triangles are right here. Let me demonstrate here. I'm going to create a new layer and draw a triangle over top. So we've got this triangle right here. Okay, there we go. Okay, and let's go ahead and move that off to the side. So we've got that triangle right there. Let's move it down here. Okay, and we've got this other triangle right here. Right here. Okay. Like so. Okay. And we can move it down. Whoops. I didn't create a new layer. Try that again. New layer. Got to get used to my drawing tools. Okay, so we got this triangle right here. Okay, let's try that here again. Oh, no, don't spin it. Move it. There we go. All right, now we got it. All right, so you can see the triangles are separated out, and their vertices are still the same. So this is A, this is A, this is E, this is D, and this is C, and this is B. Now let's say we're given some information here. Let's say we're given AD is the same as AE, and let's say we're given that angle C is congruent to angle B. Okay, so given AD is congruent to AE, and angle C is congruent to angle B. And I'm going to prove that CE is congruent to BD. Okay, so as with any good proof, we have statements and rules. Statements, we like to start with the given, so we're going to start right there. Statement 1, angle or AD is congruent to AE, and angle C is congruent to angle B. How do we know? Given. The only assumption we can make in a proof is the given. And then end, we know the proof is done when we reach CE is congruent to BD. Which number that is and what rule, I don't know yet. Okay? So like I said before, it's easiest if you separate the triangles that you're talking about and sketch them separately. And then label what you know. We know angle, or AD, is the same as AE. And we know angle C is the same as angle B. So right now I've got an angle and a side. Okay? An angle and a side. That's not enough to prove triangles congruent. For those we need side, 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 angle, 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 side, or hypotenuse leg. The key here in doing proofs with overlapping triangles is recognizing shared parts, right? We've talked about those before in the case of Siamese twins where they may share a side. In this case, the sharing is occurring because they're overlapping. And here it is right here. They both have angle A right there. They both have angle A. And angle A is congruent to itself by the reflexive property. So there's another angle. And you can see in order angle, angle, side, angle, angle, side. That is one of our proofs, one of our postulates. So we can do it. I think we can do it. So we've got step 2. Angle A is congruent to angle A. What rule says anything is congruent to itself? Congruent to angle A. That is the reflexive property. Not reflective, but reflexive. It has more to do with like the doctor hitting your knee with a rubber mallet than it does with looking in a mirror. Reflexive. Okay? And so now we've got it. We've got it right here. We've got an angle congruent to an angle. We've got an angle congruent to an angle. We've got a side congruent to a side. There's enough for angle, angle, side. So step 3 is to state the triangle is congruent. Triangle, we can go triangle AEC is congruent to, now look carefully, AEC goes with ADB. Triangle ADB. Step 3, by angle, angle, side. Now that the parts are, the triangles are congruent, we know their corresponding parts are congruent. So we can bring this up. Our last step, we know we've arrived, step 4. And how are they congruent? Why are they congruent? Because corresponding parts, so CE is congruent to BD, since corresponding parts of congruent triangles are congruent. Okay? And that's really it. That's the idea. So separate the triangles and look for shared parts. Okay? I'm going to go ahead and draw another scenario, but I'm not going to do the proof for the sake of time. But I will demonstrate how the overlapping can be not just side angles, but also sides. Okay? And here's the scenario. Let's say we've got this situation here. We've got a side shared between two triangles instead of just an angle. So like this. Okay. Now right now it looks like we just have bow ties and angles sharing a vertex, but with this line now we have overlapping triangles. A, B, C, D, okay? And the triangles are right here. New layer, boom, actually layer here, right there, okay. Ruler, okay, so we've got this triangle right here. off to the side. Okay, and a new layer. And let's do the other triangle. Right here. Okay. And drag that off. Okay, do you see, hopefully you see where the two triangles came from here, and they are overlapping. Okay, and so we'll label the vertices when you draw the separate triangles, ADB and ADC. We can see the shared side, AD, is shared, so that's congruent to itself. There's our side. Okay, and we can then get anything else that we need from the given, right? But that's where one of the facts comes from. So let's say, for example, we were told that AB was the same as DC, and we were told that BD is the same as AC. In that case, we have side, side, side in overlapping triangles. Okay. So remember the reflexive property with shared parts.